Welcome. In this video, I'll be talking about two main database characterization schemes, OLTP and OLAP. So let's begin. So databases are used in a wide variety of fields, and they're typically optimized around the workloads that they're expected to perform in. For example, databases are used in airline reservation systems, they're used for financial and banking systems, inventory management, and also in internet services, databases are used. Now, databases can be broadly classified into two types. There's OLTP, which is the online transaction processing systems, and there's the OLAP, or online analytical processing systems. Let's start with OLTP, or online transaction processing systems. These are systems that are devoted to performing transactions. Transactions are queries that insert, access, or modified a limited number of rows in a database. These transactions typically follow ACID properties, which is that these transactions must be atomic, consistent, isolated, and durable. As a practical example, if you think about an airline and their reservation system that is using a transactional database, well, they should not mix up reservations, especially if two reservations are happening at the same time, or after reservations are committed and the user is informed that they have made a successful reservation. These databases should never really forget that they ever happened. They need to be durable. The performance of an OLTP system is typically measured in the number of transactions per second. So let's take a simple example. So let's go with the airline example itself. An example of an OLTP system in airline reservations is, in fact, the database required to maintain reservations of individual passengers. So, and as an example, we have a simple table here with reservations containing the reservation ID or PNR numbers of individual flights taken by individual people and their flight dates. So using that example, a query that you can expect in an OLTP system is insertion query, where you want to book a flight for Smith on flight JK304 on a particular date using a particular PNR number. And this is a relatively simple query, which is a simple insertion query. And in this example, it's only in a single table, but it could also be across multiple tables. But the idea is this query basically affects only a limited number of rows. Not only insertions, but if you wanted to look up, all of the passengers called Smith, or if you wanted to look up a particular PNR number and retrieve the details of this particular passenger and their flight details, that's a read query, but it's also an OLTP query. Now let's switch camps to OLAP, or the online analytical processing query systems. Now in OLAP, you're going to process, data warehouses, large volumes of data to gain certain insights. Now, the data typically originates from some sort of OLTP database, for example, the airline database, or a sales database, or a inventory database, and it could be collected or ingested from other sources. For example, web server logs of individual web requests that are received at an Apache server, for example. That's a source of data for an OLAP system. Now, the type of queries that you do in OLAP are multidimensional analytical queries. So you are required to sort of combine information from multiple tables. So you might have to do a lot of join queries, and then you might have to summarize or aggregate the information that is combined from multiple tables. So you might have to calculate like a total or an average. And the data is commonly represented in a star-like schema, and I'll explain that in a second. So let's take a look at a popular OLAP benchmark to really understand what the schema of typical OLAP systems look like. So in this example, in the star schema benchmark, it's centered around orders that are placed by customers who require parts that are produced by certain suppliers, and of course these orders are created on certain dates. Now this is the exact nature of the star schema benchmark. If you look at the schema, the central table is a line order which connects customers to parts, to suppliers, and to dates. So if you wanted all of the information about a particular order, you would actually have to look up a customer or part or supplier from their respective tables. Now the design of this particular schema looks like a star. In fact, the central table in this schema, which is line order, is actually known as the fact table, because it is the table that connects all of the other tables. So it's the central table or the fact table, and the tables that are connected to the fact table are known as the dimension tables. So that's a basic idea about the star schema that is present in the star schema benchmark. So let's look at an example query, and the systems are not just, hey, let me insert a new line order. It's more about having to derive additional insights from the information that's already present in this form. So an example query in SSB is, suppose you had a discount that you were given to you're giving to a complete company, in this case a certain supplier, and you wanted to give that in a certain percentage range for all products that are shipped during a given year. And now those discounts are currently present. Now what if you eliminated those discounts? So suppose you eliminated all discounts between 20 and 30% for a particular part supplier for the year 2014. All right, so you're going to remove all of those discounts. Now the idea is, well, you need to calculate now what the revenue increase would be. So this is, after the fact analysis, and this can drive a business decision. So you wanted to see, hey, if I eliminate some of these discounts that I used to provide last year, do I actually make substantially more revenue? If so, then that can influence a business decision for the current fiscal year. You would say, hey, I want to stop giving these discounts. They're not really bringing in a lot more customers, and we are actually taking a fairly big revenue hit. So let's eliminate those discounts. So this query is actually a fairly complicated query in SQL. So in this sense, you are just retrieving the required information from the dimension tables, and associating them with the fact table, specifying ranges. You're doing a lot of joins and aggregations, and this is a query that's not generally expected to run as fast as an OLTP query. Although OLAP queries systems are also measured on their actual query performance, but you can't really expect such queries to run as fast or have as many transactions per second as a OLTP system. So let's take a look at a quick summary table about the main differences between OLTP and OLAP. So in OLTP systems, the source of the data is actually the data that the database is designed to operate on. It's the transactions. So the transactions themselves actually feed the data into a typical OLTP system. Whereas in OLAP, that data is consolidated from, say an OLTP system, from logs or from other databases. OLTP systems are used for fundamental business tasks. So, an e-commerce website that's taking care of orders from users, or an airline reservation database. Well, that OLTP system is is designed to do those fundamental business tasks, and the absence of that, you really can't run the business, So that's the purpose of data in OLTP. Whereas in OLAP, the data is used for things like planning, management, decision support. So it's used in a more strategic standpoint. So when you're having when you're required to make a business decision and you want all of the data to support your decision, well, then you usually use an OLAP system to crunch the data and give you numbers on specific business decisions that you want to make. Inserts and updates on OLTP systems are short and fast because they're part of transactional queries. They happen often in real time. Whereas on OLAP systems, inserts and updates to OLAP systems are typically done in batches. So you sort of ingest data from various sources and you run these batch jobs periodically. So sometimes they may be in the order of hours or days or even months or years. So that's how you would insert or update in an OLAP system. Now, the queries in OLTP systems, well, they're relatively simple queries, as we saw in the earlier example, and they typically return just a few records. Whereas in OLAP systems, you may have complex queries that may require data to be joined. If you have aggregations, they may return a fewer number of queries, but sometimes, these queries in OLAP systems actually might return a large number of records. The speed of OLTP queries are typically quite fast, and in fact a typical performance metric is the number of transactions you can perform per second, whereas in an OLAP system your typical queries are quite slower than OLTP systems, and of course this would depend on the length of the query and the complexity of the query, the number of joins, for example, or number of aggregations that happen inside the OLAP query. And the design of the OLTP databases, these are typically normalized. They may consist of multiple tables. OLAP may consist of fewer tables, but the key idea in OLAP is that you're using star style schemas, as we earlier saw in the star schema benchmark.